Let's take a minute or two to look at the graphs of linear functions, quadratic functions, and exponential functions. And go ahead and pause this recording, pause this video, and think about some compare and contrast items, things that are the same about these and things that are different. Go ahead and just take a few minutes to jot those compare and contrast notes down. One of the things that I did was I just kind of tried to decide if there was a way that I could, kind of explain its shape. So a linear equation, that's pretty much easy one to do. You just say, oh, it's just straight. And yeah, because we often use the word line to describe other things. So that's an easy one to describe. I often describe the quadratics as shaped like the letter U. Be sure and don't use the letter V to talk about those, because those are, if you remember back, those were absolute value graphs. But the letter U, they're shaped like that. Then these exponentials, I like to think of them like a hockey stick, okay, where you've got a flat end and then you've got the other end going up. We can really have exponentials that have the flat end and the other ends going down, and we'll talk about those as we learn more about that. But for the most part, the exponential, we think of having a flat end and then the other end going up. The next thing that I noticed is that the linear graphs and the exponential graphs have something in common, and that is that each of their y values is only associated or linked or connected to one x value. That y value right there, 1, you will only see that y value 1 for this graph when the x value is 4. That's the only time. Same thing is true over here. Let's see. Here we have a y value of 2, and the only time that y value 2 is used in this graph is when the x value was 1. It doesn't match any other time. But over here you can see on this one, on quadratics, the y's, not all y's, because this one down here only has one x, but most of the y's on here have two x's. So here's the y value 2, but the y value 2 can be found linked with the x value -1 and linked with the x value 3. Another characteristic that I found to be shared by the linear and the exponential graphs is that they're either going to be increasing over the entire graph, or they're going to be decreasing. This one right here is increasing because as I move, I'm going up as I move to the right, and that's what we consider increasing. This one right here, as we moved to the right, we're going down, so this one is described as decreasing. Same as this one over here. As I move to the right, I have to go up to stay on my graph. On this one right here, as I move to the right, I have to go down to stay on my graph. So you have to be either increasing or decreasing if you're a linear or an exponential function. But quadratics, they do both. And the reason that they do both is because they have a turning point where they turn around and change what they're doing. So this piece of this quadratic right here, as I move to the right, I have to go down. So this is where it's decreasing until we get to that turning point, and then as I move to the right, I'm moving up. So this piece right here is decreasing, and then we turn around and it starts to increase. And the opposite is true down here. On this one, I'm increasing until I get to my turning point, and then I turn around and I start decreasing. So linear and exponentials are either increasing or decreasing over the entire graph. Quadratics are doing both in every graph. They're increasing for a while and then they start decreasing. This in no way is a comprehensive list of characteristics of these graphs that that you can compare and contrast and talk about, but these are the ones that we're going to focus on for this lesson.